got kilogram times meter squared over second squared, which is the definition of a joule. All right. So we know that that's 17,640 joules. Now we've got our addition sign, and we got to do this first kinetic energy. So we got 1/2 times 90, that'll give us 45. And then times 0 squared. So we got to square the 0 first, which is still going to be 0 times 0, so 0. And then after we square it, it's still 0. 0 times anything is going to be 0. So we can go ahead and write 0 for the next quantity. All right. And again, because it's kinetic energy, we could go ahead and just write joules because we know kinetic energy is in joules. But to show you the full process, we've got kilograms times meters per second squared. So whenever you square something, you got to square the number and the units. So we square the number, that still gives us 0. We square the units, that gives us meters squared over second squared. So now kilograms times meters squared over second squared is joules again. So we can go ahead and write J for joules. J for joules. All right. So now we got subtraction over here. And we got to go ahead and do this problem. So we got 1/2 times 90 kilograms, which is going to equal our 45 kilograms. All right. Now we got to square this. So 4 squared is going to equal 16. And our units are meters squared per second squared. Okay. So now 45 times 16, we can go ahead and do that. Going to equal 720. All right. So we got 720 kilograms times meters squared per second squared, which again we know is a joule. All right. Yeah. Now, if we add all of this up, we're going to be able to solve for potential energy 2. Okay. So now we got 17,640 minus 720, and that'll equal 16,920 joules. 16,920 joules, all right, is the potential energy that she still has while that high in the air. All right, so the problem is not done yet. All right, we still have to figure out how high in the air is she. Now that's going to be a lot simpler because we know our potential energy and we know the potential energy equation. So we don't have to deal with everything else. All right. But just to review, we listed our knowns and unknowns. Okay. We found our equation. We made sure to label our variables as to whether or not it was the variable for the before scenario or the after scenario. Okay. 1 meant it was in the before scenario. 2 meant it was in the after scenario. Okay. After the event happened, which in this case was she jumped out of a plane. All right. So we had our equation. We rearranged it to solve what we were looking for. We substituted in the equations for potential energy and kinetic energy so that we could break this side apart and plug in the variables we knew. But we did not break apart the variable we were looking for, because if we broke it apart, we still wouldn't be able to find potential energy 2. So we don't want to break it apart. Next, we plugged in all of our variables into their equations and we solved. Okay. We kept it very simple. We solved it in sections, wrote the answers in sections, and then we combined them all in a calculator, and we were able to calculate this answer. All right. So now we're going to go ahead and solve for the final answer. So we know potential energy 2 now. That is 16,920 joules. All right. And now we can go ahead and solve for the height at this potential energy, right? Now, because it's the height, it says how high in the air is she at this point. We know it's delta y, because remember, delta y is talking about vertical height. y, x. Okay, so that's delta y, anything vertical. Delta x is anything horizontal. All right. So we're talking about a delta y. How high is she still? And we're talking about how high she is when this is her potential energy. Okay. Now, because this is potential energy 2, we know we're dealing with delta y 2. Okay. If we're talking about the place of the second potential energy, we know we've got to be talking about the second height. So this has got to be in the after scenario, not the before scenario. But another way you can double check that, this delta y is the delta y for the before scenario. So we know that the next delta y has to be for the after scenario. All right. So now we can go ahead and choose our equation for potential energy. All right. I put a question mark there because that's what we're looking for. So potential energy